Okay, well, I'm Brendan O'Sullivan, and I've been teaching for about 30 years. My main subject area would be physics and mathematics and junior cert science. Increasingly, I find myself more and more involved in the organisational structure of the school rather than the teaching in terms of policy development and pastoral care. Well, nationally, there are strong reservations being expressed about the competencies in literacy and numeracy, and that goes throughout all of the subject areas. It will be particularly obvious in my own subject area, both literacy and numeracy. Literacy particularly because science has got its own literacy difficulties in terms of there are a lot of specific vocabulary words. The words are quite difficult, polysyllabic words. Very often words in science have one particular meaning in science, and once they go outside the door they have a completely different meaning. Like, for example, outside we talk about the weight of a bag of sugar, whereas in science we talk about the mass of a bag of sugar. And also some words in science have, well, they may be synonymous in the real world, but in the scientific world they're not. For example, speed and velocity don't mean the same thing in science lab, whereas they do out there. Numeracy is a major problem. As far as numeracy affects, or difficulties with numeracy affect science students, generating or interpreting graphs would be one area. Working with fractions is a major problem for people. Manipulating data, manipulating, I should say, formula, simple formula like Ohm's law is V is equal to R times I. Now, if you know two of those things, you need to find the third one, and that can cause people major problems in terms of they multiply instead of divide, or they add, whatever. That causes a lot of problems. And even to the extent of being able to operate their own calculators is a difficulty, and as such it's a numeracy difficulty. Constant diligence. More and more we're becoming aware that both numeracy and literacy are whole school problems. Up until fairly recently it was thought maybe the English teachers would deal with literacy and the maths teachers would deal with numeracy. But of course it doesn't work like that. So in our own subject areas, rather than assuming a knowledge or a competence in these areas, we work directly on them. For example, in literacy, we approach each topic by having a list of key words. And by the end of the topic, the students will be able to say them, which is a big thing. Be able to, conservation, for example, is a major problem for a lot of second year students to say just that word, conservation. They say conversation, which is what they have with their pals at lunchtime. So we deal with the literacy difficulties using that strategy and other strategies, and we confront the numeracy problems head on. In other words, we teach them in conjunction with the maths department how to interpret a graph, how to add fractions. Well, there are effectively three science textbooks available, and they're all one volume works, yeah. Well, with respect, what we teach is the syllabus, and the science syllabus is prepared and published in terms of learning outcomes. Now, all of the learning outcomes will be in all of the textbooks, but it's very much for the teacher to look at the cohort of students in the classroom and decide which ones would be appropriate for which year. In other words, there's no law that says the teacher has to start at page 1 and end at page 300.
So it's up to them.
It's up to the teacher to present, to organise the sequence of learning outcomes in a way which is appropriate for the psychological development of the students or their abilities.
Gotcha.
There is another problem though with the one volume textbook: weight. It's very bad for them to be carrying them around. They do 11 subjects and all the textbooks are huge. Yeah. Their school bags are bigger than themselves.
Yeah.
And this is damaging their backs and other bits of them. I'm a big fan of technology. In my own teaching, I learned to use a PowerPoint as an educational tool about 15 years ago, when it was not popular. And since then, I use it extensively as an adjunct to my teaching because I think it's absolutely fantastic in promoting active learning among students. I don't use PowerPoint as a list of bullet points. I use PowerPoint mostly as a way to present graphics. And I find that it's absolutely wonderful to get attention and to get points across. In science, we use data logging equipment, which is another aspect of the whole area of IT. I'm a big fan of it. It has uses. People who promote it, I feel, do themselves an injustice because they over-promote it. They try to pretend that it can do everything, and it can't, but it can do a rather limited number of things extraordinarily well. It's a bit like if you look at Anne Doyle or Eileen Dunn or whoever reads the news now. Okay? Before she tells you the news, she throws out a couple of teasers, and then they play a little tune.
Yeah.
And the purpose of that is to get you thinking about, gosh, I wonder what this is about. Well, PowerPoint can be used in a similar way. You flash a picture on the screen, and you leave it there, and you say nothing. And the youngsters are looking at it, and they're thinking, what's going on here? What's this about? And this is the whole point. It gets them thinking. And then that can be the basis of a questioning session or the basis of further images down the line, rather than as a replacement for writing on the blackboard. So the regular bullet points, I feel, has very little place in PowerPoint as it might be used in an educational setting.
So a picture tells 1,000 words nearly.
As a teasers, yeah. To
and
get
then
them
you
thinking.
Can elaborate on the theories
yes,
behind
and
it.
whichever, however it's being used, every 2 or 3 or 4 slides should be a problem for the students to do. Maybe a numerical problem or a topic for them to discuss, or something to get their focus off the screen and somewhere else, to get them actively working. It's all about active learning. My experience of teachers, to put it in context, I spent a couple of years seconded from school, in the course of which I met teachers in 120 different schools, and it was most humbling for me because I rarely met a teacher who was not willing to embrace change. In my experience, the overwhelming majority of teachers are absolutely delighted to embrace change and to use whatever technology will be effective in delivering the curriculum. Now, there are a lot of technologies that teachers will not be enthusiastic about because they don't see them as an addition to the teaching and learning within the room. But if they do see the technology in that context, then yes, they were very willing to embrace that change.
And that's both teachers that have been teaching for years and have experience, and teachers that have just entered the workforce.
I'm 55 years old, and I would,
still...
anybody in my age group would be very similar, to have similar attitudes to myself. Just on that, I would think that teachers who have been around a while would have seen so much change happening in the educational system that they're probably more ready for it than youngsters who are still finding their feet and trying to come to terms with what's happening at the moment. Older teachers, I think, have seen so much change that it's just it absolutely, yeah. I think that the whole the driving force behind learning within a school context is relational. The interaction between students and their colleagues, and particularly the interaction between students and teachers. Teaching and learning is a relational art. And if the relationship is not good, then the teaching won't be good and the learning won't be good. I absolutely do. Now, there was a lot of IT packages came out let's say 10 years ago, which were, in my view, very faulty, because essentially they were composed of a question on the screen, and they kept asking you the question until you got it right. In other words, there was very little. No, putting learning in the context of gaming has a lot of advantages. First of all, youngsters enjoy it, and if they enjoy it, they do it. Quite apart from the substantive subject matter, let's say you're trying to, again, I'm a scientist, so if you're trying to teach science, quite apart from that, there are all sorts of other skills that the youngsters will learn as a result of the gaming, rather than just learning the subject as such. I'm a big fan of it, but having said that, I couldn't really list a lot of examples of how it has been used successfully, not in my subject area anyway.
Do you see it as something that could be worked on and brought into the classroom?
I'd be hugely enthusiastic about it.
But you haven't
but
seen
I haven't
yet.
seen a concrete example that I could say to you, Jason, this is absolutely brilliant and they're all going to get A's from having done this. I haven't seen such an example. But the notion of incorporating gaming into their learning process, I'd be very much in favour of that. But not obviously, well, maybe it's not obvious, but not as a replacement, but as an adjunct to what's happening already.
Oh, yeah.
Well, we use quite a lot in, not so much for juniors as for senior physics, the whole notion of applets, where you familiar with applets? Yeah, where you can alter the parameters yourself on the screen and observe the consequences of the alteration. I mean, they are hugely effective. And again, like a picture speaks 1,000 words. It's very easy to get a concept across using an applet, very much more so than by talking or by writing. Again, I don't really see a situation where it's either an experiment on the bench or an applet on the screen, because very often there is no point of intersection between them. Bench experiments can be quite different to what one would use an applet for. So, for example, you can use an applet to explain why, if you fire a cannonball fast enough, it'll go into orbit. You couldn't possibly carry out that experiment on the bench.
Oh, yeah.
Do you know what I mean? Yeah. On the other hand, if you're doing, for example, experiments in sound and strings and tensions and that's best done on the bench, because it's three-dimensional and it's real life, whereas it can be simulated on an applet, but not as effectively or with the same efficacy. Well, I think it's a way. I'm a major fan of them. I've given you one reason already, because particularly smaller students carrying very weighty bags around, it's a health hazard, and it's a serious health hazard, whereas an iPad will carry the same textbooks at a tiny fraction of the weight. And the iPad, particularly more so than the laptop, thank you, are being very strongly promoted at the moment, or iPads and similar tablets. They have their limitations. There are cost implications, and we're not living in a lot of families are very stuck for cash at the moment. A lot of families. They can't do everything a book can do. No, you can have an ebook on a tablet and you can read it by flicking the screen, and it's very effective that way. But it's not as, for example, accessing the index and that at the back. It's not as user friendly in some ways. But I would be very much in favour of the introduction of that system, at least to partly fulfil the needs of the students. But I would have to say that I know of a number of schools, some of which are in this part of the country, who have, with a lot of bells and whistles, introduced themselves as IT schools and had laptops for every student, but that hasn't worked for them.
And it hasn't worked?
It hasn't worked, no. If all schools had a very good broadband connection, then it would be used. But it's not going to change everything. It's not going to take over the planet and be the centre of the educational process. But it's certainly, as an adjunct, extraordinarily useful. Even something like introducing a YouTube clip into the middle of a lesson. It's absolutely fantastic. And it touches on cultural norms that instantly the students resonate with. I don't have strong thoughts on that. If I could just, by the way, backtrack for a little bit in terms of broadband and how to use it. We're piloting a system here in this school, VLE, a virtual learning environment, where we place resources on a bit of our school website, which are accessible to the students from home, and that is proving successful. Now, we have only started to do it in a quite limited way at the moment because we're finding our feet, we're only sticking our toes in the water here. But it looks fantastic. It has a lovely, very doable feel to it, and we're enthusiastic about it. Now, again, it's not going to replace everything, but as an add-on to what we're offering here, I think it's going to be very useful.
And what sort of content is available to the students?
Any content that the teacher thinks appropriate. So, for example, if I was teaching reflection of light today, I could put a PowerPoint on reflection of light up on the VLE folder, and possibly put a worksheet with it that the students would work their way through, while they'd have the PowerPoint on half the screen, and but the content is entirely at the discretion of the teacher. And
would you ever maybe link external videos that wouldn't be necessarily something that you use?
Yeah, absolutely. And that facility is there. Rather than downloading, we'll say a clip from YouTube, you can just put the URL there, and that works beautifully. And there's a very neat system to do that, where you don't even have to copy and paste it. It's just a couple of right clicks and you're in. In a utopian world, that might possibly work, but I find the content, the teaching materials that I use change from year to year, and not necessarily because last year's ones were bad, but because it's very important to match what you do with who you're doing it with.
The students.
So the methodologies have to be matched to the students. So there's a school 2 minutes down the road, and their students are different to my students, so my PowerPoints or my worksheets or my essay titles would not necessarily suit them.
Okay.
So in terms of universal sharing of knowledge, I'm not sure that that's going to take off. In terms of social networking, as in Facebook or LinkedIn or those things, I'm not altogether convinced that they can be usefully adopted as a tool for teaching and learning, because they're already pretty well established in what they do. And what I mean by that is, once youngsters get in there, their behaviour patterns are already established. So they're going to spend an hour chatting to their pals, or seeing who's online, or admiring one another's photographs and that sort of thing, rather than getting on with what
it's not really controlled.
Yeah. So they sort of, most people have sort of fallen into a pattern of what they do on those sites now. Students love science. In our experience, they just love it. They love the activity end of it. They love the way that it expands their mind in ways that other subjects don't. Now, unfortunately, they're subject to the same cultural norms as everybody else, and they don't like the work that goes with it. So nobody likes having to sit down and learn off whatever it might be, Newton's laws off by heart, or that there's a strong resistance to that. Now, the way science is taught, there are 6 science teachers in this school. No two of us teach the same way.
They're all different.
Absolutely, yeah. Couldn't be more different. So it's not then the way science is taught as much as the ways science is taught. But no matter how you try to dress it up, and some people like the bells and whistles approach. Other students, of course, much prefer to sit in a quiet class and take notes off a blackboard. That's what they like, and that it's whatever flow. But so the ways that science is being taught have changed radically over the years. But there seems to be a cultural resistance when the learning slope gets too steep, that people tend to back off. But again, which is where we came in, a big part of the difficulty that students experience with going ahead with science, and people in third level will tell you this as well as ourselves, that when people in go into third level, they can't write essays on account of they're essentially illiterate and numerate. So the literacy and numeracy problems are a major impediment there, yeah.
It's the simple kind of beginner sort
yeah.
of.
Yeah, in junior cert science, as you say, it's not so much where science starts taking off, because they do science is a big part of the primary curriculum now. So science education is a continuum, starting from day one.
Yeah.
And of course, a lot of science education happens in everyday life as well, particularly in the biology end of it.
Yeah.
But I suppose junior cert is where science begins to use a very specific vocabulary and begins to use the scientific method in terms of rigorous experimental methods and having controls and all that. So it's where science begins to be scientific.
Academic.
Yeah, rather than phenomenological or observational.